Super. ఖాళీ టైంలో అది ఊపిరి తయారు చేయమన్నారు. ఏమంటారు అవ్వలేదు.
So we'll start the class in a minute. ATL Purimal Kapur. Spotlight enable the innovation for others. Read the names of annotation leaders. Read video panel. I read a voting meeting control. Share computer sound.
నేను 3D వీడియో పెట్టరు కదా సార్ ఇక్కడ ఇది డిఆర్
Good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. Once again, I welcome all the class 6th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter. The chapter number 8 is the last chapter of the material, Fun with Magnet. And today we are entering into the session number 3. So we have completed 2 sessions on understanding the basic properties of or basic structure of a magnet under the heading of Fun with Magnet. So we'll continue where we left in the last class. But before that, let us recall, let us review what we learned in the last 2 sessions about the fun with the magnets. Right? So as you can see, as per our material, so what we learn, you can see here. First, we learn about what is the history of the magnet, where the magnetism first started around the 800 BC, means almost 2826 years back. The word magnet is used by Greek philosophers, which is observed by a shepherd. I clearly explained you the story also by single picture, how shepherd is walking around a hill area called Magnesia, where he found that a black colored stone attracts his stick strongly, and that stone is identified as a natural magnet, lodestone, or a magnetite. The chemical formula is Fe3O4. That is the only natural magnet other than our earth. So we have seen what are the natural magnets, what are artificial magnets. So as per the demand, as natural magnet is not so strong, not so perfect, so the man started manufacturing the artificial magnets as per our requirements. So we have various appliances where magnets are used, which are of different shapes and different powers. So they are called artificial magnet, which are made by a man, which may be either in the form of bar magnet, in the form of ring magnet, in the form of disc magnet, in the form of needle magnet, or horseshoe magnet, and many more are there. So in last class, we discussed about the terminology. When you are discussing magnetism, there are so many terms we'll come across, like magnetic poles, which are the common terms we use. Every magnet will have a pair of poles, that is north and south poles. They are named whenever a magnet is suspended through a thread, it comes towards rest, or it always shows north-south direction. The side of the magnet which is showing north side is called north pole, south pole is called south pole. Like that, we can identify the poles of the magnet where the total magnetic power is concentrated. We have seen experiment also, right? Then what is magnetic axis? It is an imaginary line. When you imagine that a line passes through the magnet horizontally, an imaginary line passing through the magnet horizontally is called magnetic axis. Then magnetic length. So as you know, length we commonly measure with the either scale or tape, which is the two extreme ends of the magnet. Easily you can measure by using the scale. That is called length of magnet. But it is different from the geometrical magnetic length. Geometrical length is different from magnetic length. Geometrical length is the distance between the two extreme ends we can measure with any device. But magnetic length is different, which is the distance from north pole to south pole, which is 80% of the geometrical length. Suppose geometrical length is 100 centimeters, magnetic length is 80 centimeters. That is, the formula is given by the scientist in that time. Because we cannot exactly locate where is the north pole in the magnet, where is the south pole. So they imagine that they are at the 80% of the geometrical length. Formula also given. Magnetic length is equal to 5/6 of the geometrical length. So you can give magnetic length and ask to find out the geometrical length, or you may give geometrical length and ask to find out the magnetic length. We can use a formula. Magnetic length is equal to 5/6 or 80% of geometrical length. Right? The very important part. Then equatorial line. Equatorial, word itself indicates which divides the magnet into two equal parts, passing through the axial line or passing through the magnetic axis. That line is called equatorial line. Okay, so then we have seen what is a magnetic meridian, what is the geometric pole. So separately we discussed about what is the north pole and south pole. And magnetic compass, very important one. The last, what we discussed in the last class, compass, which is commonly used to show the direction. Navigators are in, either you are in water, you are in air or on ground. Everywhere we use the navigator, just like your Google. How Google showing the direction from the starting point to the your destination. So even navigators, when they are in the ships, they use this magnetic compass to show the direction. Similarly, aeroplane also you can see you can find the compass. It is simply made up of, if that is original magnet in the form of a needle. Original magnet, that is magnetite, is used here with a circular, a calibrated scale indicating north, south, east, west directions, and the needle is placed at the center. As it is made up of natural magnet, it is always directed towards the north and south. It is covered by a glass so that you can see visible clearly without any disturbance. So that is, you can find here, of course, nowadays we are not using, we are finding the same compass in our app also, by which you can see the direction, right? So up to here we learned in the last class. So you can see now what is a temporary magnet and permanent magnet. So some magnetic materials, as we discussed in last class, some magnetic materials retains the magnetism permanently, whereas some magnetic materials loses the magnetic property within no time. Those who are retaining the magnetic property for long time are called permanent magnets, right? Like stainless steel, which loses the magnetic properties very soon, early, or as long as magnetic field is there, they are like behaves like a magnet. But when magnetic field is removed, they lose the magnetic property. So they are called temporary magnets, right? So generally permanent magnets are made up of various alloys, mixture of metals, like Alnico is the best material to get the permanent magnet. Alnico, aluminum, nickel and cobalt mixed in a different percent ratios as a alloy. That alloy can be converted into a magnet. That is a permanent magnet, whereas others comes under the temporary magnets or weak magnets. Okay, then, so as I already told, magnetic field, you know, particular field. What is the field? Magnetic field means, suppose I kept a magnet with me. In front of me, one magnet is there. If I keep iron piece at my home, can it attract? No. Good answer. Why? Because the magnet will have some power up to certain range, up to certain region. Correct or not? That region is called magnetic field. The space around the magnet, the region around the magnet where it influence is felt. Suppose if you take MLA is there, MLA of one constancy. That MLA constancy's power is only applicable within his constancy. Malakpat MLA cannot go to the Secunderabad constancy and you cannot rule. CM is there. Telangana CM cannot rule Andhra Pradesh because the Telangana CM region is only in Telangana. Modi cannot lead the US, going USA, he cannot become the Prime Minister because his region is only within India. Similarly, magnet also has its own region, the space around it, where its influence is felt, where it can attract the magnetic materials. Such region, such space is called magnetic field. Right? So how do you may ask, sir, how to know the magnetic field? How can we know magnetic field? That we can draw also. Magnetic field can be detected by simple experiment. Take one compass, so one magnet, bar magnet, placed on white sheet at the center. White, you take one drawing sheet placed on the floor. Place your magnet at the center of the white paper and draw the outlines. Right? As you can see in the figure. You can see in video also, I'll show you. Right? After placing, you take one small compass. Small compass, right? You take small compass starting from North Pole. Place the compass at North Pole. See the direction of the needle. Place one dot there, marker. Then again remove the compass and place the next point. Like that, move the compass as per the direction of the needle. So you can find so many points around the North Pole to South Pole. Join all the points. We'll get the mark like this. See, you can see the picture here. So whenever you are starting from the North Pole, the compass starting from North Pole, here it is coming towards the South Pole like this, and here. Like that, you can draw the so many lines around the magnet. See, here why you are not getting the lines? Because magnetic field is not there. At the center, you can see how strong the lines are. But when you come to a certain region, they are disconnecting. Lights are disconnecting because magnetic field become weaker. When you are moving away from the magnet, its field becomes weak. That is the reason you cannot get the lines clearly. These lines are called magnetic lines of force. They are called magnetic lines of force, which always comes out from the North Pole and terminates towards the South Pole. Always comes from the North Pole to South Pole. See, they are always parallel to each other. No two lines of forces intersect with each other. See how beautiful diagram you can see here. No line is intersecting. They are just passing parallel to each other. And you can give a wonderful shape also. Design. Like that you can draw. We cannot see that. We cannot see the power of magnetic field. But accordingly, we can draw the lines of forces to understand how much strong magnet is. So, the lines of force are the lines around the magnet, which always starts from the North Pole and terminates at the South Pole, which are parallel to each other. No two lines of forces intersect with each other. Okay, you can, after going home today, you can try, if you have magnet, you can try these lines of force. Or simple, another experiment also there. Take some iron pieces, iron fillings, you can say, iron powder, placed on one paper. From the bottom of the paper, you move the magnet. See, here on top of my hand, there is a iron fillings are there. Iron fillings means small iron pieces, powder like iron pieces. Place the magnet at the bottom of the paper and move like this. Automatically, the iron fillings on the top will rearrange. They align. They rearrange like a same lines of forces. We'll get a wonderful shape like this. That clearly indicates how magnetic lines can be drawn and what is the strength of magnetic field or what is the strength of a magnet. Right? So that can be drawn here. What I told you, like this you can draw by using a small compass. This is all the procedure what I told. Right? So that is about the magnetic lines of force. The lines around the magnet, which always starts from North Pole and terminates at South Pole, which are parallel to each other. No two lines of forces intersect with each other, which can be drawn, as I told, on drawing sheet by using a magnet and a small compass. Right? Okay. Now the next part is magnetic materials. Already yesterday we have seen one video on this. Magnetic materials. The materials that are attracted by a magnet are called magnetic materials. Suppose In front of you, there are so many objects are there. You have pencil, you have eraser, you have compass box, you have lunch box, you have water bottle, right? Everybody will have. You keep all in front of you. You have paper, that is notebook. Everything you keep in front of you on table. Bring one magnet, ask your teacher to get one magnet and try. Your hairpin or your safety pin, everything you place it on table. Bring one magnet and try which one is attracting to the magnet. Understood or not? That is the thing the scientists have done. The materials which are strongly attracted by magnet are called magnetic materials. Right? Which are attracted by magnet. Some of them may be strongly attracted, some of them may be feebly or slightly attracted. But they are called as a magnetic materials. So magnetic materials are of three types again. What are that? One is diamagnetic material, paramagnetic material, and ferromagnetic materials. Right? Very important explanation. So magnetic materials are those which are attracted by a magnet, which are of three types. In that first one you can see. First one is diamagnetic materials. These materials which are repelled by a magnet, means they are not at all attracted. They are completely unaffected by a magnet. Like hydrogen, gas, mercury, alcohol, gold, bismuth, water. These are the materials which are completely repelled or unaffected by a magnet. Materials which are unaffected by a magnet are called diamagnetic materials. Why they are not unaffected, I'll tell later. You come across in higher classes. But they are not at all attracted. They are repelled. Next, paramagnetic substances. The materials are which are weakly attracted. Weakly means slightly. We can call it as slightly. Or you can call it as even feebly. Magnet are called paramagnetic material. Example C. Magnesium, manganese, aluminum, platinum, chromium, oxygen, and solutions of salt. Means whenever salt dissolves in some solution, the salt solution is also a paramagnetic materials. Right? When you add salt into water, pure water is a diamagnetic, but salt water is a ferromagnetic. Clear? Now, next one, ferromagnetic, very important for us. These are the very important materials. The materials which are strongly attracted, by a magnet are called ferromagnetic materials. Right? They are strongly attracted. See examples. Iron, nickel, cobalt, gadolinium, dysprosium, right? And even the alloys of that. When the metals are combined with each other also, they can be attracted by magnet. Not only attracted, they are used to prepare the magnets. Only ferromagnetic materials are used to prepare artificial magnets. That means they can be magnetized. Right? So a mixture of ferric oxides and barium oxide is a strongly magnetic. It is commonly called as ferrite. Ferrite is used for making very powerful magnets for radios and transistors. So not only individual nickel, iron, cobalt, the alloys like ferrites. Ferrites are nothing but ferric oxide and barium oxide. They combined and they are used to make the magnet. Right? They are called ferromagnetic material, which are plays very important role. Not only as a ferromagnetic, also can be used for preparation of a powerful magnets. Clear? Now, non-magnetic substance. They are the magnetic substance. Ferro, para, dia. Non-magnetic. The substances neither attracted by magnet nor converted into artificial magnet. Neither you can use for attraction purpose nor they can be, right? they are called non-magnetic substances. Example, glass, wood, paper, brass, stones, chinaware, mica, ebonite, etc. are the example of non-magnetic material. Or you can check whatever is there in front of you. You can immediately check which are attracting to the magnet, immediately which are slowly attracting or which are not attracting. So like that we can classify the magnetic and non-magnetic materials based on their behavior in the magnetic field. In magnetic field, how they are behaving. Clear? Now, properties of magnet. Whenever first time they got the magnet in the form of black stone, they studied the properties first. So first, a magnet attracts magnetic substances. When a magnet of a magnet broken, each piece becomes a complete magnet. I told yesterday, you break magnet into any number of pieces. Each piece will get with the pair of magnet poles. Every piece will get north and south pole. We cannot separate north and south pole of a magnet till now. Still, so many things are going on, work is going on. But right now, nobody is separated north and south pole. They try to separate also. Each piece comes with the north and south pole. When a magnet is suspended freely, it points in the north and south direction. You all know. This property is called directive property. And this property is called attractive property. So it attracts the magnetic materials. It always shows north and south direction. If a magnet is heated or handled roughly, it loses the magnetism. This is called demagnetization. Suppose if you have magnet with you, rough handling means if you throw here and there, you drop from some height or if you heat, what happened? It loses the magnetic property. And that process is called demagnetization, removal of magnetic property. By heating or hammering or rough handling or throwing from some height, in all these cases, the magnet will lose the magnetic property. Unlike poles of magnet attracts each other and like poles repulse each other. Very interesting. This is called law of magnetism. What it is called? Law of magnetism. Suppose see, south, north, south and north will attract. If north and north is there, they repel. So, unlike poles attracts each other, like poles repulse each other. And this is the property of magnetism. It's called law of magnetism. Attractive property, directive property, demagnetization, law of magnetism. All these are the properties of a magnet. What they are? Properties. Okay. And if you cut magnet into any number of pieces, each piece exists with the pair of poles. Okay, right? So before going for the further, let me show you one video on the properties of the magnet as well as some uses also you can see.
Magnets are not just fascinating objects, they also play an essential role in our daily lives. From the moment we wake up to the time we go to bed, magnets surround us. Magnets play a crucial role in our everyday lives. We find them in objects we use regularly, such as refrigerators, compasses, toys, gadgets, speakers, and even electricity.
Everywhere you can find the magnet.
Today, we are going to learn about magnets. And by the end of this video, students will be able to know what a magnet is, identify magnetic and non-magnetic materials, understand the properties of magnets. Let's start knowing what a magnet is. A magnet is an object that attracts or pulls magnetic material toward itself, and has the power to attract certain materials like iron, steel, nickel, and cobalt. Did you know that some rocks are natural magnets? Lodestone is a natural magnet that occurs naturally in the Earth's crust. These fascinating rocks have been used by sailors in the past to navigate and find their way. While man-made magnets are made up of magnetic materials such as iron or steel. One common way to make a man-made magnet is by rubbing a piece of iron with a strong magnet. They are used in many everyday items, such as refrigerator magnets, air condition, and more. And now, let's explore the various shapes of magnets. Magnets come in different forms. Here are some of the most common ones: bar, horseshoe, rod, and ring-shaped magnets. Magnets can be classified
Whichever
into two
shape you
main
want, you can-
categories: magnetic and non-magnetic materials. Let's explore the properties of each type. Magnetic. These materials are attracted to magnets and can be magnetized. The most common magnetic
Please
materials
enjoy,
are
just like a fun.
iron, nickel, and cobalt. Examples of objects made up of these materials are keys, paper clips, wrenches, and scissors. And non-magnetic. Non-magnetic materials are not attracted to magnets. They cannot be magnetized. The most common magnetic materials are plastic, rubber, wood, and glass. Some examples of objects that are made of these materials are a soccer ball, a teddy bear, a plastic water bottle, and a wooden guitar. Did you know
Please
that
enjoy.
magnets have the power to attract and repel? That's right.
Properties.
One of the
That's
most
what we
exciting
discussed.
properties of magnets is their ability to attract certain materials and repel others. Magnets have a special power called magnetism that allows them to attract certain objects, like paper clips and coins. Magnets have two ends, called poles: a south pole and a north pole. Magnets exhibit the properties of attraction and repulsion.
See, that is.
Opposite poles attract each other,
Opposite pole
while like
attracts.
poles repel each other.
Like poles repel.
Magnets create an invisible force field around themselves that produces a pulling force, called a magnetic field. This field is responsible for the magnet's ability to attract or repel other magnets and magnetic materials. Just like a giant magnet, Earth creates a force field around itself, which helps
Magnetic
protect us
lines.
from the sun's powerful rays. It acts like a giant shield, keeping us safe from harmful particles. So, while we may not see it, Earth's magnetism is always working behind the scenes to keep
But
us
magnet, it's
protected
what
and our
Terrestrial
planet spinning
magnet here.
smoothly.
Magnetic property. You know, magnet
In
also,
summary,
Earth also has a
magnets are
northern zone.
amazing objects with a wide range of interesting properties, including the ability to attract and repel, appear in a variety of shapes, its magnetic field,
Yeah,
and be
okay.
found in many everyday items.
Quiz time. Grab a pencil and paper.
Right, anyway. Can you participate? You can check once.
And get ready.
The timer is going on. 3, 2, 1. Go. First question. Dash your object attracts, pulls the magnetic material towards itself. Magnet. Right. There is questions. You have to give the timer. If you can do, you can answer. Right now, cannot answer here. So it is a natural magnet that occurs nature in the earth crust. That is only magnetite. You can write magnetite. Right. Anyway, this we can see in the next time. We'll move to the right. So this is about the properties of magnet: attracting property, directive property, and demagnetization, and also the law of magnetism. Like poles attracts, unlike poles repels each other. You can do by activity how it will exactly works, how the magnet can pull the magnetic materials, right? That all is a fun. Now, Demagnetization. You know all. Magnetization is nothing but converting magnetic material into magnet. For example, you have steel iron with you. Iron. By using one magnet, we can convert the iron into magnet. The process of converting magnetic material into a magnet is called magnetism. That is magnetization. But here it is demagnetization, means removal of magnetic property. I told rough handling, dropping from certain height, heating or hammering. All these can make the magnet to lose the property. You have to keep the magnet. You have to protect the magnet under certain conditions, away from all these things. Right? So this is here, demagnetization. A process in which magnet loses its magnetic property is called demagnetization. Whenever magnetization is just its reverse, this process of converting magnetic material into magnet is called magnetism. Converting magnetic material into magnet is called magnetism. Converting magnet into magnetic material is called demagnetization. So demagnetization can be done by rough handling, throwing here and there, by heating, by dropping from certain height, or by keeping like poles opposite each other, placed forcefully north and north pole. Even though they are repelling, if you hold like this, after some time, both magnets will lose the magnetic property because of the continuous repulsion. Because of the continuous repulsion. That is called demagnetization. Right? So there are some activities are there, and we'll see in the next class why, explanation for the activities, few activities, reason for that, and finally by the uses of magnet. In the last class when you meet on Friday, we'll complete the total material. Right? So till then, what we have learned today is we have seen more and more about the magnetic properties and what is the magnetic lines of force, and again record the history. See here how the molecules are arranging. That is called magnetization. Whereas left side you can see south and north are attracting. That is unlike poles repulse. So this is demagnetization. Observe carefully right and left. The right side one shows how the magnetization and demagnetization, and left side how unlike poles attracts each other. Right? So this is the biggest magnet, how it is attracting magnetic materials. So that's all for today's students. Have a wonderful day. Thank you, all of you. Thank you. Mm.